Alright, this is FRQ1 for set number 6. Part A wants us to find total time. So let's go ahead and find max height first. We are going to use common form in the y direction. Make sure we label everything correctly. Okay. So we know at max height that there is no Vy. And we know A in the y direction is G. Go ahead. So we know that Viy is equal to Vi sine theta. So we can go ahead and plug that in. So Vi is 50. And then sine theta, which happens to be 37, is equal to 0.6. This is squared over 2g. So 50 times 0.6, 30 squared. And then it was negative, so negative 900. And g they want us to put as 10. So 2 times 10, 20, duh. And then we go ahead and, and we have to remember that gravity is negative, so that would also be negative. So then you take 900 divided by 20 because the negatives would cancel out and give you a positive. So this height here is 45. Okay. Alright, so now what we can do is find the time it takes to get to point A. So we go ahead and just set up the Stitz formula, but again, in the y direction. So we're going to use this 45 because we're just doing this path right here. So 45, we found our VIY was 50 times 0.6, because remember VIY, just ignore the squared, is going to be 30. And then 1/2, and this is going to be G again, so 10 squared. And we have to remember G is negative. This would actually be minus. So what we want to do is set it equal to 0, so we have something to plug into our quadratic solver. Okay, so we can go ahead and plug this in. Oh, you can't even see that, sorry. Okay, so you get t equals 3. Okay, so for the time, so it takes 3 seconds to get to point A. So I'm gonna write 3 seconds. Okay, now what we're gonna do is find the time it takes to get from point A to point C. Okay, so we're gonna go ahead And again, set up our distance formula, again in the y direction. This time, however, so looking at our diagram now, we started above ground, 35 meters, and then we went up even more, 45. So to find our change in y, because we're going from A to C, and C is at the ground, we need to add 35 and 45. So you get 80. And now 80 is negative because you're going down. So negative. And again, we have no Vy at the top. So that cancels out. And I'm just left with 1/2 -10. Simplify. Again, negatives would cancel out. So it's going to be positive 16 square root. We know that that is 4. So from here, from point A to point C, that's 4 seconds. So what we can do is just add 3 plus 4 equals 7 seconds. So that is total flight time. On to part B. Part B wants us to find the horizontal distance r that the projectile travels before it hits the ground. Okay, so for this one, we're going to go ahead and look in the x direction now. So we can set up position because we're trying to find the x distance. Okay, and we know that there is no acceleration in the x direction. And then, so Vix is equal to Vi cosine theta. So that's going to be 50 cosine theta is 0. Can you see that? Okay, 0.8. And then t, which we found to be 7. Alright, we'll just go ahead, plug this all in. And that gets you 280 meters. Alright, on to the final part, part C. C wants us to find the speed of the projectile at points A, B, and C. Alright. Okay, so point A, we're at the tippy top. Okay, so let's start off that we know Vy is going to equal 0 because at the top it is only Vx, and we know that Vx is equal to V cosine theta, and we also know that in the x direction, again, there is no acceleration, so we don't need to calculate a new Vx. So this is just 50 times 0.8, because cosine of our theta is 0.8. And that gets you 40. And so we know, again, no Vy at the top. It is only Vx. So that is our speed at point A. Okay, point B is right here. So we know there is no acceleration in the x direction, so that means Vx stays the same throughout. So that means at point B, it's going to be 40. But we also know that, so a projectile makes a parabola shape. And since point B is at the same spot or the same level as the initial starting point, we know that V is going to be the same. So that means V is going to be 50, but we can also calculate that just to prove it. So let's go ahead and do that. So our VF formula, so VYF is equal to VIY plus AT. All right, so let's go ahead and start from point A just because it's easier because there is no Vy, so that means this will be 0. And now we just have -10. Now we need to figure out which time we are going to use. So we're at point B, correct? So we know it took 3 seconds to get to point A. And again, point B is at the same y displacement as the starting point. So that means it would also take 3 seconds for the projectile to get from point A to point B, so we can go ahead and use 3, and that gets us -30, but it wants us to find speed, so it's just 30 meters per second at point B. All right, last but not least, speed at point C. Okay, so again, we know no acceleration in the x direction, so Vx is going to stay the same. Let's go ahead and find Vy. We're going to use this VF formula again. All right. And again, let's start at point A, so that way this is just 0. So you get 10 for acceleration because it's gravity. Now we need to figure out our t. So now we're going from point A to point C. We already found that time to be 4. Oh my gosh, I did part B wrong. Okay, wait, let's go back really quick. Okay, so I only found Vy. It wants the speed. Okay, so let's ignore this box. Okay, sorry, brain fart. I was too excited to move on. Okay, so to find V, we can use kind of like the Pythagorean theorem. So we get V squared equals Vx squared plus Vy squared. So we can go ahead and just, oh, that's right, because we were proving that this is going to be 50. Okay, so we can go ahead and plug in everything. Oops. Okay, so there we go. Our V, or speed, is equal to 50. Like I said, because it's the same horizontal displacement. So it's going to be even because it's a parabola, so it's going to, you can kind of like fold it and imagine it's going to be the same thing on both sides. So that is that. Sorry about that. Okay, back to point C. So no acceleration in the x, so v will stay the same. We are looking for vy now. So we set up our vi function. Acceleration in the y direction is gravity, and we're using 4 seconds because now we're starting from point A going to point C, and we found that time to be 4 seconds. So let's go ahead and plug that, or multiply, get -40. And then again, we're going to use this formula. So 40 squared plus 40 squared. Get that to be 56.57 meters per second. Alright, that concludes FRQ 1.